Hello, this video is about how we can have the mole map and these heat concepts come into one big part. So this is heat in the mole map. It's on page 525 to 529 in your textbook if you want to read along, or certainly come ask me for help. Let's just dive right in. Okay, first thing is we've got to talk about thermochemical equations and what that kind of means. Here, this is actually a thermochemical equation, and I know that because it has the chemistry part, the equation. You can see that with calcium oxide and water. But it also has this H thing on the side, and the H thing we have seen, and that actually talks about enthalpy. So this part is the thermo part, the heat part, and this part is the chemistry part. So this H is called enthalpy, which we kind of covered, and enthalpy is just a fancy word for heat. Now they're not exactly the same. Technically heat is Q, but if we're not changing the pressure, which we're not, then H and Q are exactly the same thing. When H and Q aren't different, that's an AP topic, so I'll let you do that in AP. But taking a look at this equation, we can see that it is a negative change in enthalpy. A negative change in enthalpy means it's releasing heat, giving away heat. If you're releasing heat, you've got an exothermic reaction. So this above reaction is exothermic, and I know that because in the equation it tells me it's a negative H value, or negative heat. Okay, so now what we're going to do is actually use this H value. Here's another thermochemical equation. You can see the thermo part is on the right here. My enthalpy is 129 kilojoules. It happens to be a positive value, so this one is an endothermic reaction. Alright, it says, if I have 2.24 moles of sodium bicarbonate, how many kilojoules of heat are needed to decompose this? It says kilojoules of heat are needed, and that makes sense. In this endothermic, we have to input heat to make this reaction happen. So my question would be, question mark, kilojoules equals 2.24 moles of NaHCO3. This is a mole map problem. I kind of know that because I see a balanced equation. This is probably a good place to go. I'll put moles of NaHCO3 on the bottom. That way they'll cancel. And I'm trying to get to kilojoules, so let's put that on top. So now I gotta look at my reaction. Well, I try to find something that has kilojoules in it. The only place is this number here. So I'm going to put 129 on top. Then I got to ask myself, well, 129 kilojoules, that's what's needed to convert how many moles? Go to your balanced equation. This 2 represents moles. 2 moles. 2 moles of sodium bicarbonate will require 129 kilojoules. So that's my fraction. At this point, I just need to bust out my calculator. My calculator spits out 144.48. Considering sig figs, this is a conversion factor, it's infinite sig figs. But my beginning one isn't. There are 3 sig figs here. 3 is the lower number between 3 and infinity, so this is 144 kilojoules. And that'll do it. So, thinking about our mole map, here's a picture of a mole map. We just used a conversion factor where we went from moles to heat. So here's my 2 moles spot. I thought we'd stick in the value right here, to heat. Heat has units of kilojoules mostly. You could also have units of calories, or kilocalories, or little calories, all those different kinds, or joules. Either way, the conversion factor we used for this was the enthalpy that's at the end of the reaction. So we use enthalpy and the number of moles according to the balanced equation to allow us to go from moles to heat. Alright, here's your problem. How many kilojoules of heat are produced, this is an exothermic, from the synthesis of 32 grams of aluminum? So I'd like to ask, have you solve this problem? How many kilojoules are produced when you've got 32 grams of aluminum? Please solve this problem and put it into your Google form. And if you have any other questions, let me know also in the Google form and we'll answer them the next day. That's all I got. Have a good night.